This video is going to be about making what are called scatter plots. A scatter plot is on an XY coordinate grid, the Cartesian coordinate system, where you're plotting a whole bunch of ordered pairs like this. Okay, now just a quick reminder before we start plotting these, that when you graph an ordered pair, the first number is the X number and the second number is the Y number. This is a left-right direction. This is a up-down direction. The x-axis goes like this. The y-axis goes like this. Okay, so this first point is going to be over 1, up 5. This one is left 3, up 2 from the origin, and so on and so on. Okay, so I've already gone ahead and graphed these so that you don't have to wait and see me graph them. So I'll just go ahead and show you the graph. Okay, this is my graph of all of these points. Okay, now there's just a quick review of stuff. Let's look at these points and identify some intercepts, just because we've practiced that before. Our intercepts have to have zeros in them. Okay, this has a 0, this has a 0, this has a 0. Anything with a 0 is an intercept. So remember that if x is 0, going this direction, you went 0. You started at 0, 0, the origin, you went 0, and then you went either up or down. That means it's going to be on the y-axis. If x is 0, it's a y-intercept. So I'm going to circle all of the y-intercepts here if x is 0. Okay, I should have 3 y-intercepts. Just double check on my graph. Do I have 3 dots on the y-axis? Yes, I do. I have them right here, here, and here. Likewise, I have 3 x-intercepts. That means y is 0. So let's double check. Do I have 3 x-intercepts? Is y 0? I have them at 1, 2, and where's my other one? Oh, here it is, 3. I knew I had 3 of them, so I have 3 x-intercepts and 3 y-intercepts. That's just a review. It has nothing to do with the problem. Just making sure that you guys remember that if you have a 0 in your point, it's an intercept. Okay, so I've already taken and graphed all these. And this is my scatter plot. Now, once you've graphed your scatter plot, or you see a scatter plot, there's a few things you want to notice. You want to notice if there's any trends. Is there a trend with these? Like, do they seem to be going in an uphill pattern, in a downhill pattern, or is there no pattern at all? It's kind of like imagining putting a rectangle around the dots and seeing what direction is the rectangle going in. Now, you don't have to put everything in the rectangle. You just want to have the vast majority. So I'm going to put a rectangle around these dots. You can see that I've got 2 dots that didn't fit in the rectangle, but if I tried to fit those, it wouldn't be much of a rectangle. It'd be a big square and there wouldn't be any pattern. But the way that I drew this with these 2 that are outside of here, which yes, they are outliers, this tends to be going in an uphill pattern. From left to right, you read this like anything, it's going uphill. So since this is going uphill, it's going to have a positive correlation. Okay, correlation means that these variables are affecting each other. Whatever this graph is about, as the x value goes up, the y value goes up as well. Okay, so let's check that. If let's just pick out 2 points here and just double check it. If I pick 2 points in the box, and I'm going to double check if they're going in a positive correlation, then as one of them gets bigger, the other one also gets bigger. So the ordered pairs of these are left 1, 2, 3, 4, down 1, left 4, down 1, and then over 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 4, 7. So I said as x got bigger, y got bigger. So -4 went to +4, that definitely got bigger, and -1 went to 7, that definitely got bigger. As one went up, the other one went up. Now, the same phenomenon is as one goes down, the other one goes down. So if I would have just put these in the other order, I would have said 4 goes to -4, that goes down, and 7 goes to -1, that goes down. So positive correlation is one goes up, the other goes up. Or one goes down, the other goes down. Now you can figure out that just based on that, negative correlation will be as one goes up, the other goes down. As one goes down, the other goes up. That's negative correlation. Now I'm not going to give you an example of that, but it would just mean that the box would be going downhill. Now, if it seems to appear that there's no pattern at all, like they're just sort of random dots all over the place, and you can't put a rectangle around them, then it would mean that there is no correlation. In other words, one value does not affect the other value. Let's say, for example, my grades and my hair color. My grades in high school and my hair color, blonde, did not affect each other. I know there were blonde jokes. It could say I'm not very smart because I'm blonde, but no, they don't affect each other, obviously, right? My eye color and my shoe size have nothing to do with each other. If I tried to plot that, which I couldn't by the way, because eye color is not a numerical value, so I couldn't put it on here anyway. You get the point. Okay, this is positive correlation. Now, the next thing we're going to do is we're going to draw what's called a line of best fit. Okay, now a line of best fit, I put best in quotes because it's not going to be the exact line. There is software to find what's called the exact best line, and then it's called a regression line, linear regression line. You could put all these dots into a computer, into a program, and it will draw the best line for you. It'll calculate everything. But we're just going to do an estimated line of best fit, and we're going to say it's the best fit. But what we need to do is try to draw the line so that we've got equal dots on each side of the line. And I say equal because it might not be possible to split the dots in half. You may end up with 2 on the left and 1 on the right or whatever, but you want to try to get them as equal as possible. You also want to minimize what are called residuals. Now, residuals are going to be the dots that are off the line. How far away from the line are they? We want them to be as close to the line as possible, reducing all of those residuals. I'll show you what I mean. Then we're going to come up with the line, and this is the formula for a line, y equals mx plus b. This is the slope-intercept form of any linear equation. Shouldn't be the first time you've heard this. M is the slope. B is the y-intercept, which we already know we found some y-intercepts because they just mean that x is 0. So we're gonna draw our best fit line. Then we're gonna pick 2 points on that line and calculate our slope. Okay? So here is my example. I'm going to erase the circles around those dots because they really didn't have anything to do with anything except for me showing you that it was positive correlation. But now what I need to do is try to draw a line through these. Now I'm going to draw with a straight edge here so that I can try to draw it as straight as possible. But I'm trying to minimize residuals, and I'm trying to get as many as possible on the line and split the rest of them in half. This could be kind of hard, but I'm going to draw it. Okay, just a second. My marker decided to be weird. Okay, that's not the best, but there's my line. All right, so what I'm going to do first is I'm going to count how many are on the above and how many are below. I have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Well, I have 8 above and 6 below. 1, 2, 3, 4, 5, 6 below, and 1, 2, 3, 4, 5, 6, 7, 8 above. I'm not including these outliers because there's one of each. Because I have 8 and 6, that indicates I could have made it 7 and 7. Let's see if there's anywhere obvious that I could change this line. I don't really see anything too obvious. So I'm just going to be okay with this. Remember, it's the line of best fit. As long as you're showing your work and showing your teacher like what you need to do, they're not going to, or at least I won't, say it's the wrong one as long as you have it close. It's not the correlation. It's not going to be the linear regression formula. It's going to be a close one. So this is close enough for me. All right, so then I'm going to take 2 points that are on the line. They have to be on the line so I can calculate the slope of it. And the points I picked on the line are over -2, 0. And let's go -1, 1. Okay, I picked these 2 points, -2, 0, and -1, 1. I could have picked this point. I only have 3 points on the line. You just need to pick 2 of them. Then I'm going to calculate the slope. All right. So remember that your slope is the change in the y values over the change in the x values. My points are -2, 0, and -1, -1. I mean -1, 1. So my y values are 1 minus 0 over -1 minus -2. That's y minus y over x minus x. Y minus y over x minus x. 1 minus 0 is 1. -1 minus a -2 is -1 plus +2, which is 1. 1 over 1 is 1, so my slope is 1. Okay, my slope is 1. That means wherever I am on my line, if I go up 1 and over 1, I will still be on my line. Just check that here. Sorry, I gotta grab a different color marker. If my slope is 1, I should be able to start anywhere on it and go up 1 over 1. 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 And so on and so on and so on. It works. All those dots are up 1 over 1 on the line. Now what I need to do is find my y-intercept. Okay, well, luckily, my line goes through my y-intercept, and my y-intercept is right here at over 0 up 2. But let's say that it didn't, and I needed to calculate it. Okay, that means that I'm going to take these 2 points, pick one of them. I'll pick my -1, 1, and I'm going to put them into y equals mx plus b. I'm going to use this point. My m is 1, my x is -1, my y is 1. So I've got y equals mx plus b. Replace a y with 1, m with 1 because we calculated it as 1, x with -1 plus b. 1 equals 1 times -1 plus b. That's 1 equals -1 plus b. Add 1, I get 2 is b. My equation of this line is y equals 1x plus 2. Y equals 1x plus 2. My slope was 1. We already can see that on the graph, but we had used these 2 points to calculate y minus y over x minus x. Then we plugged in a y value. If I would have picked this y value, it would have worked as well. Y equals m times x plus b. Then I solved it for b and got b as 2. And guess what? Over 0 up 2 is our y-intercept. We already saw that. You're not going to get that lucky, but that is our y-intercept. Now, we got one more thing to say about this. We know it's positive correlation. It has a +1 slope, so that makes sense. It's going in an uphill direction. That means the x values and the y values are going up together or going down together. But we want to know how closely correlated is this? How closely correlated? Okay, so now we're going to have something called a correlation coefficient, or an R value. All right, R values go from -1 to +1, and they tell you how closely correlated they are. How much does one affect the other one? A negative is going to be going downhill. Since our line is going uphill, we're going to have a positive correlation. It's not the slope of the line. Our slope was 1. It's a number that you're going to have to put into this website to calculate. It's SOSSCI, 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 like social science, statistics.com, SOSSCI statistics.com. Then you plug in it's very self-explanatory. You plug in all your x values and you plug in all your y values, which I know I had 25 points. It took me a minute, but that's okay. It's a whole lot better than telling you this nasty formula. Ugh, I don't even want to do this formula. I plugged them in, and this is the correlation coefficient I got, 0.3859. So basically 0.4. Okay. 1 is a perfectly correlated, perfect straight line. Every single dot is on the line. Okay. -1 is a perfect correlation as well, only it's going to be going downhill and every dot's going to be on the line. So as we start getting dots off the line, we're closer and closer to being, as we start getting dots off the line, we start figuring out how close to the line are they. Now, I had talked about residuals before. These are my residuals. If I draw a vertical line, I'm going to erase my red lines from my slope. If I draw a vertical line from each dot that's not on the line to the line. I'll show you what I mean. These are my residuals, okay? This dot was this far below the line. This dot was this far above the line. What we're trying to do when we draw our line is reduce our residuals. We're trying to make them as small as possible. Now, I didn't even include these two outliers here because they're so far, they're out of the box, they're outliers. If I calculated a mean, they would be completely skewing that mean. So chances are real statisticians would leave those two dots completely off because they're outliers and they're going to skew the data. And we're only going to look at these dots, but we're going to find these residuals. Now, what the correlation, the correlation coefficient calculator is doing is it's basically averaging these out. So it's taking one that's equal distance below and equal distance above and canceling them off. So I can kind of erase the ones that cancel each other out. I've got this tiny little one below and this tiny little one above. I erase those. This one is 1, 2, 3 units below. This is basically 3 units above. I can kind of erase those. This one and this one kind of erase each other. And you see what I'm trying to do is minimize these residuals where I have ones that cancel each other out and I have as few as possible below. Now, when I get this and I've erased everything from the bottom and I still have, except for this tiny little one, well, these two could be erased. They could cancel each other out. I still end up with 2 of them on top and none of them on the bottom. And that kind of worries me a tad because originally I said I had 6 dots above, 7 dots below, or whatever it was. And I could have redrawn it to be 7 and 7 and be more equal. Imagine if this residual was below, then they would be equal. It probably would have been a perfect 1 correlation then. And since it wasn't, it was a 0.38. We know it's very closely correlated, but it's not perfect. So 0.38 does make sense because it means it's a very close correlation. 0.38 is pretty close to 1. So I'm okay with the fact that I have 2 of them left over here. All right, so that is basically just explaining the correlation coefficient. Well, what you guys are going to be expected to do is just look at numbers like a correlation coefficient of 1.3. What does that mean? Oh, it means it's not possible because they only go from -1 to +1. I meant to say something like maybe a correlation coefficient of -0.9. What does that mean? It's going downhill and it's very close to -1. So the dots are very close to the line, or the residuals will basically cancel each other off. Tightly correlated, closer to 1. Looser around where you can't cross off any residuals, going to be closer to 0 where there isn't as much of a correlation. There you go.